Finally getting to play with my 64 Dodge Plymouth. It's a Dodge Dart wagon out of Canada, and they never really had the Dart model, so it's a Valiant. So the grill, everything like that all looks like Valiant. Anyway, identical. I may call it a Dodge Dart just because that's easier than Valiant, whatever. I've been trying to order Scarebirds brakes because originally when I got the car I thought, man, I want to design a front brake kit for it that fits the stock rims. And then I found that Scarebird already makes one, and I'm, perfectly willing to save myself the grief and the headache of trying to design one. Okay. With the information, I've been trying to buy it for over a month now, well over a month now. I got a hold of them, and it took them at least a week. They got great parts kind of thing, but they're like super slow. I don't know what the deal is with it. The last time I emailed them was probably close to 3 weeks ago, and I still haven't heard back from that one. Anyway, so I know from their design that they're using roughly a 1/4 inch thick plate and caliper mounts on the front because you can't use the sway bar, which makes it a lot easier because you don't have to worry about clearance with the tie rod end. If it did have a sway bar, I'm kind of thinking you could clock it up here, but looking at their stuff, the piston for the caliper, the body of it, sits right in this opening here, okay? And so that would mean that you wouldn't be able to clock it up. It'd be a lot easier to design a kit for like 16-inch rims using a 12-inch rotor. Not my flavor, I don't really want to do that. And so anyway, with all disclosures and everything like that, I'm showing you what I'm doing, okay? And I may not even post this, but I'm going to go through with what I'm looking at and what I consider and stuff like that, and take into account measuring and everything like that to design my own, okay? Now, I'm not going, originally, I took some other video, and I think I posted it on Instagram, that had to do with, looking at rotors I already had, G20 Infinity rotors and stuff like that, and calipers. I've got Willwood and Nissan calipers laying around here, stuff like that, and I couldn't find anything that really worked nice. What they use is Celebrity calipers, which I'll probably show them at some point when I'm measuring them and stuff like that. They have a very small profile that comes up away from the rotor and in front of the rotor. And then the rotors are Previas. Cadillac, there's a Cadillac rotor I was just looking at, in the Cadillac Eldorado, used the same rotors front and back. They're a little bit thicker, but I think I'm going to be looking to use the Cadillac calipers on the back. They're on order right now. I haven't got them in, so I know they'll easily fit the rotor because this is a under 0.9 rotor, and that one's roughly an inch rotor, so it's about 100,000 difference. I know I'm going to be doing a flat plate, piece of cake then, so I need to check the clearance I need here. Okay, so you can see how there's a raised boss here, and it kind of goes back in here. And all I did was, if I took the backing plate off, everything like that, you could see it hanging over there. And then I just backed these bolts out. They're tight. I had to ratchet them the entire way to get them back that far. I don't see any reason to take them completely out. I don't believe these are threaded. But since they backed out with a ratchet, that was easier than going to getting a hammer and trying to hammer them out and stuff. But I only need them out that far so I can get a better look at the hole and stuff like that. And I can check the diameters and stuff like that. So these are also raised up a little bit higher. I think I might go get a wire wheel. I was originally planning on just taking these off and sandblasting them and stuff like that. And I don't know that I'm going to bother doing that. But I think I will go get a wire wheel and see if I can't clean that up just a little bit. Tell you what, I went through and I put high flow fittings on everything. It's got a little leak. I'm guessing it's in the tool itself. Yeah. might be in that fitting. Anyway, this thing's got a lot more speed and torque than it used to have. And I started to say before, in taking this apart, this is just simply what I'm doing, okay? And I'm not going to go through and do some of the, like showing how to take that backing plate off. One, there's a lot of videos on the line and stuff like that that, you know, will probably show that. But here's the thing, if you don't know enough about mechanics and cars and shit like that to get to this point to begin with, you've got no business trying to create your own brake kit, okay? Yeah, that's all there is to it. So you can follow along kind of thing. No, I do not plan on doing this, creating these for anybody else, because Scarebird has already done it. So just buy theirs, and the price is decent. So I'm not doing this because I'm trying to avoid a price. I'm just kind of tired of waiting, and I enjoy doing this part of it, the creation and stuff like that. I figured out multiple disc brakes kits to convert drums from on Datsuns. Okay, this is my first more or less non-Datsun. Well, I think I'm pretty good. I might go get the other tool with the Scotch-Brite wheel and shine it just a little more. And I walked away from the camera for a couple minutes there, but so I'll edit that part out. But I don't know just how picky when I did a lot of these before, all that stumbling on my words, saying you know, I don't know how much I'm going to do to try to eliminate that these days, because doing that makes the video editing such a royal pain in the ass. If I have to go through and do that to get people to watch, then I'm not going to bother. They can watch somebody else. That's nice and pretty. That's certainly nice enough. You know, if I took them off, I could make them nice and pretty with, you know, sandblasting, glass beading, whatever. At this point in time, don't have any desire to turn it into a show car. I would like it if it was nice and presentable. Okay, so I got it cleaned up nice, stuff like that. We'll start taking some measurements. There's a chance I may put the drum brakes back on, get it running. I'm not in any hurry to get it out of the driveway kind of thing. It would be nice before too long. I really thought I was going to have this thing up and running and drivable, at least to, you know, run to work once or twice, you know, long months ago. But apparently not. I may do the front setup, depending on how long that takes me. I may then do the backs. I don't know. It should be fairly simple. So I'm going to try to get enough measurements on here that I may, I'll get to doing some designing on it, stuff like that. We'll see how fast things move forward. So anyway, I'm making a sketch over here with my TV tray. And like on the Datsuns, I needed to make a adapter to change the bearing that I could use. And on this one, I don't need to do it because I'm going to be using the drum hub with the drum bearings and stuff like that. Man, they're tiny. I'll tell you what. Granted, this car wouldn't handle the same load because the Datsun pickup is, you know, rated for like a half a ton. But still, it's way smaller than I thought it would be. I guess that would be one reason to change these up. But I want to figure it out for the small rims, the 5-on-4 bolt pattern. It's a bastardized bolt pattern. Nobody makes rims for it, anything like that. I have rally wheels. I don't know that I need too much dimension-wise on the spindles themselves. I mainly need these holes, the diameters for the bolts that I need those holes to, how big those holes need to be. And then I need to get an idea how big this center hole is going to be, because this boss does stick above this by a certain amount. Kind of hard to tell. So, you know, if I were to use like 3/8 inch, and this car is probably light enough, I could probably use like 1/2 inch aluminum and make the brackets. And then I could more easily CNC machine them. So I haven't decided yet, because if you do steel brackets, then like the brackets I thought I was going to buy, they weld nuts onto the backside to be able to get enough thread, because 1/4 inch plate wouldn't give you enough material to thread. You could thread it, you could bolt to it, not enough that I would trust it. Okay, so let's see here. Basically 0.44. That's .490, 495. I'm going to write it down as .495 because I'll check that, and that may not be exactly a half-inch hole. It may be it's not 7/16, but somewhere in between there, you know, 15, 30 seconds or something like that. And the two bottom holes are the same, two top holes are the same. So I got the measurements on those two different sizes of bolt holes. Now what I need is spacing between them. Okay, so I can go to the outside here and do 4.44, we'll call it 0. To the outside, that's 4.440. Okay, and then you can come and do to the inside 3.56. Okay, the difference between that is 2 holes. So you take that difference and then subtract half of it. 4.44 minus 3.56 equals 0.88. And since I was at basically 0.44 per hole, that's where the 0.88 comes up, I want to subtract half of that. Okay, and that should put me in the middle of those holes. It's going to make it 4 inches even. Okay, if I subtract it from the big one. Still, comes out to exactly 4 inches. And that you know, is completely believable and plausible. You know, they're not going to set it to, you know, 4.1 unless they really had to, you know. What would be the point? So just as a little bit of verification, we're going to set that on 4. We're going to hold it up there and look and go, yeah, they both look to be in the middle. Okay, these holes are different and they look to be a little closer together. Okay, so let's do it again here. So 4.3. Then we go back the other way. And this is why I push those bolts in farther. So that's pretty much every bit of 3.3. It's 3.298. So I'm going to put it down as 3.3. Oh, well, yeah. That gives exactly a 1 inch difference. Half of that is 0.5. So if we add 0.5 to the small one, that's going to make it 3.8. And if we subtract it from the large one, that's going to make it 3.8. So 3.8, cool. Okay, now I need to get the vertical distance. And at this time, I'm just going to assume that these holes are centered on the spindle. It wouldn't really make any sense for them not to be, but it's possible. I can bring the backing plate back out here, and it would be easy enough to check from the edge of the center hole to the edge of, you know, any one of these, and I would check it from the center, from the edge to that. I may show that, we'll see. And I can also more or less assume that these are going to be the same spacing. Okay, that's a little more off. Part of that is because the hole diameter changes. Okay, that's the combined total of the 2 holes. Once I get that divided by 2, that should still put me to the middle. 0.94, which sounds about right because I had 0.44 for the top hole and 0.5 for the bottom hole, or 0.495. So that puts it really close. 0.94 would be a half inch plus 0.44. If I divide that by 2, that will give me half of each hole basically. Now I got 0.47. And if I subtract 0.47 from the 3.6, I get 3.13. If I add it to the 2.66, 0.47, I get 3.13. Let's now put this on 3.13. And with this one, I can change this, and that's 17/128. That's an oddball size. 79.5 millimeters. So we'll check it. Oh, the reason I said it's not extremely critical is I'll go draw this up in CAD, and with I can come down with a paper template and put it on here with the holes cut out and stuff like that and check it and see if I like it or not. Or since I have the 3D printers, I will probably print a bracket And then I can actually come down and I can actually put the bolts in it and everything like that and mount the caliper up. Even PLA should be strong enough for that, so we'll see what I printed out of. Yeah, that looks pretty damn close to the center. I'm going to go down to 3 inches even, just kind of as a sanity check, because it would seem to me that 3 inches would be a better number for it, but oh, it's definitely not 3 inches. That's about 1/8 of an inch off. And 0.13, that's right around 1/8 of an inch. So, you know, there's a good chance it's 3 1/8, as opposed to 3.13. Actually, I'm going to put it at 3.125. You know, that looks even better. I'm going to call it 3.125 because these holes look like they were cast as opposed to drilled or machined or whatever. They're just not that pretty. So, you know, there might be a slight discrepancy there, so 3.125. And go from there. That kind of makes sense. And, you know, if it's actually 5 thousandths difference, you know, I'll find out when I print the bracket and stuff like that and check it out. Here's the reality. For 5 thousandths, the discrepancy on drilling a hole would account for that anyway. So I really don't have to worry about that. So I want to try to figure out how the distance between these two. There's 1 or 2 ways I could do that. I need the diameter of that. I want to get I want to get a measurement of the whole width of that so that I can at least get this distance from center, so that I can recreate that, so that when the caliper goes on, I'll have a better idea there. Okay, so what was I after? Let's see. 3.3. So that's more than 3 1/4. I'm gonna probably want to do it at 3.75. 3 3/8. Yeah, see, and that gives me a little bit of wiggle room, almost roughly 1/8 of an inch. Okay, and if I go this way, the top is flat, but I'd rather just cut a round hole than to try to, you know, make that top hole round. If I'm having it laser cut, or even if I'm doing it on a CNC machine, I could make it so when I do the test print and the check and stuff like that, I could account for this and make the hole not round, but I will probably just end up making it round. Everything seems pretty symmetric, and like I assumed that these holes are centered over the center of the spindle, I'm going to do the same thing for the dimension I need here, and I'm just going to, you know, this isn't extremely accurate, but it looks like 4.43, yeah, 4.43, so from the center. Oh, and actually it's half that. Okay. It's not 4.43, it's 2.215. We'll call it 2.2. And the reality is that since it's a flat plate, okay, that's going to come off here and hold the caliper over here. And it looks like, since the body of the caliper, the piston area, has to go into this notch, it's going to come straight out. If it was coming out over here, like I explained earlier, hopefully I made it on camera, it would have to be clocked up. And when it's clocked up, then I got to pay attention to other things. Now, on the Datsuns, the only option was I took one of the ears off, okay? But then I made it out of 3/8 inch steel, so, you know, it was more than strong enough kind of thing. But I really don't want to do that on this. I probably could, but there's no reason, I don't have to, okay? I don't have to have the caliper in the back, and if I put it up front, I don't have to clock it either way. I don't have a sway bar. I don't know how many of the cars of this, you know, this model and vintage and everything like that had them either. I don't think it's a big issue. Oh, let's see here. One thing that is not centered, these holes are not centered here. So that might be a little bit of a challenge to figure out. I could probably eyeball it. Close enough. 3/8. That looks pretty dang close. Okay, maybe it's just an optical illusion. I'll figure it out when I print the paper template to start with. This is a lot less shallow of a curve than this is here, so it makes these ears look like they're down further. Oh yeah, can you see that? Let's see. Let me try to get it more square on with the camera. That hole is definitely further up compared to these. Okay. 0.9. Yeah, I think that's basically the same. Stamped steel. Maybe not extremely accurate. So let's call it, what did I say it was? 15/16? Let's call it 0.92. Now that's just from the edge there. Oh, so I guess I need the diameter of that. I was looking all over it. I couldn't find the damn, and they were under something else. So then when I pulled the set out, guess what? I have 2 sets of them. So maybe I need to put the second set, put them in 2 different places, kind of, you know, help me next time. So 2.44. And I need that because of, I go from that to these dimensions to make it even and stuff like that. So that'll be a bit of a challenge in CAD to try to, at least for me, because I'm not that good, to figure out exactly where where they are. Okay, it's kind of hard to figure out exactly where center is to be able to go, you know, from here to here and here to here. To draw this in CAD, get it kind of close, print out a 1:1, which is a pain in the ass on Windows 11. Oh man, I hate Windows 11. God, oh, it's just like 10 with a couple extra features. No, they screwed up a couple of those extra features. Yeah, oh, don't get me started on that rant. Then I print it and I come down, and then I can, you know, since I'll have the circle, all the holes printed, then when I come down and I put it behind here, basically, I go from the other side, I can see how far off they are. And then I can go up and I can move whatever hole, the center hole, how I need to move it. And it's going to move just on the axis up and down, I'm sure. It's not going to be, you know, at an angle or anything. So I move it up or down a little bit, print another sheet, come down and take a look. So I did the measurements as close as I could, that kind of thing. Got that done. Another trick that can be done in CAD is using a picture as a reference. And so I'm going to try to get right over the hole, and since that wall inside here has got a slight taper to it, what I'm looking for in here is to try to get that taper centered. Because the camera's not completely centered on here, so I can't just go, oh, there, that's where it's at. That's pretty dang close. So what I'll do is I can import that as a canvas, and since I know the spacing on the holes, I can scale it basically, and I could do a sketch on here, like 3-point circles, to create each of these and the center hole, then tell it, you know, okay, this is exactly, or these are exactly 4 inches apart, and then I can reference my scale to that. And so it should come out pretty close first time.